Hey, so I'm calling this video Radial Forces and Caching. It'll be pretty clear why by the end of it. And by the end of it, you'll have this result, is that you can have the other tank fire a projectile at you, or vice versa, of course, and you will knock each other for 6. So I'll see you in there. So let's take stock and ask that question, what's least fun about this game? Well, being able to fire that often and having 200 rounds is a bit crazy on a tank. So I'm going to go to the tank aiming component, give myself a 2-second reload time and 20 rounds, just to make that more sensible. Right, let's put an enemy tank back in the scene and play the game. I'll depossess and use F11 and F8 to depossess, then F11 to go full screen. Okay, what happens when the explosion hits us? Okay, well, it's okay. Firstly, the tank isn't moving. Let's make that our first focus. We've also got these balls stacking up, and that's no good. And also we want to turn off the brown balls and we want to get rid of this smoke. But let's focus on adding a force so that we actually knock my tank out of the way. So how are we going to do that? Well, let's go and look at the projectile and see in the blueprint what we have if we search for components that relate to force. And we have this thing here called a radial force, used to emit a radial force or impulse that can affect physics objects and or destructible objects. Well, I think we all get a sense of what a force is. It's something that causes an acceleration. But what is an impulse? Well, you can go on Wikipedia and look up an impulse. You'll get a bit of maths. It tells you that it's the integral of f dt, which means it is the area under the force time graph. If you do a Google image search for impulse force graph, you'll see that you've got an idea of seconds or milliseconds and then an amount of force. An explosion would be something like this. A force would rapidly rise while the air pressure rises and then it would drop off. And what an impulse is it's the area under that curve. So what this add radial force as an impulse allows you to do is do exactly that, add a fixed impulse. It could be 100 million newtons for 1 second, or it could be 10 times smaller force for 10 times longer, or 10 times bigger force for 10 times less time, as long as the area, as long as the multiple of those two is the equivalent, okay? So the way we're going to add that is as we've added all the other things in the projectile. Let's go to the projectile header file, and let's make ourselves the appropriate type to start with. So let's borrow the code for let's borrow the annotation, the U property. And then it's going to be a U, now let's see if we can find it, radial force component. That was easy to find. It has the same name as in the blueprint. It's a pointer. I'm going to call it an explosion force. And we're going to be good boys and girls and initialize it to the null pointer like that. Fantastic. All right, so we now have a local variable to store the explosion force. Now let's go and actually add the explosion force as a default subobject. So explosion force equals create default subobject U radial force component, and then let's just give it a simple name, F name with a capital N, and I'm just going to call it explosion force. So let's not bother with attach to component for the moment. We've done it with the launch blast. We haven't done it with projectile movement. We have done it with the impact blast. Let's see if it's necessary. So let's go ahead and compile our code and take a look at the projectile blueprint when we do so and see what happens. In fact, while I'm compiling my code, let's be nice to you and show you my code changes. That's the header file code changes there, and the C++ code changes are there. Remember, you can always go to github.com/Ben Tristram, navigate through to Unreal, find the section, and get the code. All right, so has that compiled? That's the question. Looks like it may have done. Compile succeeded. I'm just going to save all. I've got a lot of stars here. I don't like stars. Stars mean unsaved work that could get lost if Unreal crashed. Would it crash? But in case it does. Now let's look at the projectile. Explosion force. There we go. Collision mesh, launch blast, impact blast, explosion force, and projectile movement are all sitting there. Okay, great. So there's the explosion force. Now, how do we know how much explosion force to set on this? Well, we need a radius. 2 meters, okay. Maybe we go to 5 meters. Our tanks are 7 meters long. And then this talks about the fall off. So it's a constant fall off in this case. After 5 meters, there is no force. So it's going to be a 5 meter blast area. Now, how much impulse strength do we need? Well, remember what the definition is. It's the force times the time. It's more subtle than that because it's actually an integral under a curve. But let's imagine it's a constant force for a minute, a square curve like this one down here. How would we even get an idea as to how much impulse we need to give here? Well, one very easy way to get an idea is to go look at the tracks and see how much force we have, driving force-wise. We have 1, 2, 3, 4, 5, 6 zeros and a 40. So we have 40 million newtons. So how about with our projectile impulse here, we imagine that we apply, I don't know, 100 million newtons, the same force as both tank tracks driving, plus a bit, and we apply that for, say, 1 second, the duration of the explosion. Then we get 100 million. Let's try it, because it's 100 million times 1 second. So 100, 1, 2, 3, 4, 5, 6. Okay, there you go. That is the, let's try that as a starting impulse strength. Now, Unreal crashed. Luckily, I'd saved everything, so we shouldn't lose any work. Again, a single crash like that, not that unusual when you're changing blueprints. Let's go and restore everything. Have a look over here at the explosion force. Turn the radius back, and then set this guy back to 100 million. Trying not to curse because of the crash. Okay, fantastic. Let's compile that. Now let's play the game. So I've applied this explosion force as on the object, but we need to code for that explosion force to actually do something. So the way that you do that is you come into the where the actual hit happens here, and you say explosion force, and then you go through the arrow pointer, and you fire impulse. There's no parameters on that, but you just fire the impulse that has been set up in the component. We, in our case, have overridden that in Blueprint. Let's just try going ahead and recompiling. Then we should get a force firing off when the component hits the tank. So let's go and see if that works or if it doesn't work. So it fires, it hits, but the tank's not moving. Okay, so we could doubt our size of our impulse. It would be very reasonable to doubt that impulse and say it should be bigger. But it's not actually the size of the impulse that's causing the problem. I'm actually leading you down a path here on purpose. There is a problem already here on the screen, but it's going to lead to some very interesting debugging attitude and behavior. So what I'm going to do now is turn up that radius to say 1 to 1,000 meters. So 1,000, If I turn up the radius to 1,000, shouldn't need to be 1,000, but look at this. Think it will work now. Then you're going to have a challenge to work out why. Now the tank goes flying backwards. Okay, now let's look at that a little bit more carefully. If I just get into the tank here and move, if I can move before he shoots me, can I just... Look at this. What's quite interesting is me and the other tank are both heading backwards when that impulse force goes off. So what is going on here? And that's your job. That's your job, is to work out what is going on in this case. Let me get you to the challenge slide. Find the bug, basically, is what you need to do. Because it's a really interesting bug. It's not actually a bug as such, we're just slightly misusing the engine, but it is important. So why is this behavior happening? Try inspecting the projectile at runtime. Pause the game, depossess, inspect the projectile, look at all its components, particularly the explosion force one. See if you can find out what's going wrong. If you can, write a single line of code. It's a line of code we've already written in the C++ files. And see if you can solve the problems. Share the solution and your approach to the problem in the discussions. Spend a little bit of time scratching your head, because this is the sort of thing that you might come across in your own use of the engine. And I want you to be prepared, both in terms of the skills to debug it, but also in terms of the attitude. Take a positive attitude to this. Say, I can solve this. This is solvable, you know? So go ahead, pause the video and take a look now. Okay, welcome back. So let's just play the game. F8 to depossess. I'm going to move to the side. When the projectile's in flight, I'm going to pause it. I'm going to click on it. Let's take a look at it. What's funny about this projectile? Well, there it is in the world, sitting doing its thing. Let's just look through the components. Fine. Now, explosion force. Look where the projectile itself is. Look at the location in the world. You can see the indicator there. And the collision mesh, and the launch blast, and the impact blast, all going along with it. But where's the explosion force? There it is. It's at the root of the game. It's at 0, 0. Well, I don't know actually if it is exactly at the root, but that probably is actually relative to the tank. Yeah, that's probably at 0, 0, 0 position in the world. If you want to be sure, of course, you can come to modes. You can add yourself a cube to the world. I would scale it 10, 10, 10, or you could have just used the padlock to do that. Reset it to the origin. Actually, yeah, you can see it is. So the explosion force is ending up at the world's origin. Why is that? Let me show you another thing that's weird about the explosion force. Look at the impact blast and the launch blast. I did that round the wrong way, but you get the idea. Look at its transform. It has a location, rotation, and scale. Look at the transform on the explosion force. Only has a scale. No rotation or location. It's knackered, to use a technical term. Now, this is why. Congratulations if you found this. Because we didn't bother to attach to component. Okay, so going to grab that line. In fact, we don't need to update to the new API because we've done that. We do need to attach. If we don't attach, it will look like it is attached to the collision mesh, but it ain't working. So we need to put this attached to component line in. Okay, and because I've done it there, I'm also going to do it on the, actually we don't need it on the projectile movement, because if you look at the projectile movement, it sits differently. It doesn't sit as a child of the collision mesh. It doesn't need to go along with the collision mesh. It can just stay in the world where the projectile launched. So we don't need to bother with that, but we certainly do with this explosion force. So let's go ahead, compile the code. Then I'll save all as well. I can do that now. I want to get rid of my stars. Stars are a bad thing. As I say, it's work that could easily get lost. And isn't that an interesting, strange bug, right? That you just, the only symptom was that transform wasn't working. Let's have a look here. Explosion force now. Explosion force now actually still doesn't have a sensible looking transform. And this is now probably because of caching. Unreal Engine tends to cache things, often for performance, too much for its own good, I would say. And you can end up with these types of problems where that change should have made it work properly, but it isn't. So let's take a look now if that's helped. If it hasn't, we have to do what? What do we do if this hasn't helped? We have to refresh the intermediate files, don't we? So look, that hasn't helped. I can recompile the blueprint. I'm definitely, okay, another problem. I said I'm definitely attaching the right component. That's easy to do. You borrow the code, but you use the wrong thing. Okay, so that can give you a problem as well. It needs to be the explosion force that attaches. That was my fault in this case. But that's a different issue, right? The reason it didn't attach is because I used the wrong variable name there, which you could have done the first time round, by the way. You may have done that had you just automatically come in and copied that line. This is the problem with copying and pasting lines, but it doesn't remove from the underlying problem that if you don't attach, which either by using the wrong variable name here or by not having the line altogether like we didn't have in the beginning, then it looks like it's attached, but it doesn't act like it's attached. Okay, so now, this is interesting. If we recompile now, looking at the explosion force, if I've written this code properly, attached to component, you would hope that when I look at this explosion force component, that it has its transform working. It doesn't. Let's try closing and reloading Unreal. Does that do it? It may not do it. So we're going around this cycle twice here because I want to bring home the fact that not only do we have to attach these things, but it can also cache the state. Look, now it's back just by closing and reloading Unreal. You see how difficult to diagnose that can be. Now that this explosion force has a reasonable looking transform, I suspect we'll be able to turn the radius back down to 5 meters, because now the explosion force won't be acting from the middle of the world anymore. It'll be, ooh, what's going on with my camera? Hang on a second. Okay, that's better. I suspect it won't be acting from the middle of the world anymore, but it'll be acting where we want it to. So that missed me, and that hit me sideways. You see what's happening there? Great. So, very interesting problem. It's showing you the problems with caching in Unreal. So remember, some things are cached. Even though I changed that variable name back and recompiled, it still didn't have the correct transform. And yes, you need, when you actually want your hierarchy to look like this, you absolutely have to attach to. Otherwise, it will look like it's attached and it won't be. The thing to watch out for is that all of your components have that this is a proper transform for the root component, but any subcomponents need to also, apart from just having a scale, have to have a relative location and rotation compared to that root component. So flick through them and keep your eye here on the right-hand side of the screen under the transform, okay? Really valuable stuff. That'll get you out of lots of trouble in future in Unreal. So I'm just going to close the engine right now. Actually, I won't close it, but I'll leave it there, save everything, and I will see you in the next video.